Okay guys, so we'll be doing the next dash, which is number one, list length. So write a function that returns the number of elements in a linked list. So this one is going to return the number of elements. How many elements? So it's not the value right now, so it's the number. So as you can see, we have the prototype, and then it has an unsigned integer, and then this is the name of the function, list int, right? The length, right? And then it has a constant this and that, which is the was it the struct, and then it has the header, pointer to the header file, right? A pointer to the header file, um, which is used to iterate through the list. So what basically we are going to be doing is, if you let me click on this guide I used to explain. Let's see load. Okay, so it's just basically like the former one we did, but the difference is that the former one will just remove the printing of the data, right? That's all. So it's pretty much of that. So what we want to do is, like, we have this list, right? This list contains three um, nodes, right? Three data. So we want to count it, okay? And they've given us this head, right? That is the pointer to the head. That's that each is the head that has been given to us, right? So we'll first say, okay, if this head is pointing to null directly, it means that there's nothing inside, so it should return. But if it is not, then it should count it, and then we are going to use this guy to count. Okay, so we'll get into it, and then we'll see how it works, and then I'll explain one more time so you can get to it. So the first thing we'll do is we'll copy the prototype as usual and paste it inside. um, we'll paste it inside the what's it called, the header file, right? So I'll do the vilist.h, right? So I'll come down and I, right? So I'll save that. So we've done the basics, so this one will be much more faster. So we'll do the one main.c to test our file, right? And copy this guy. So I'll vi my one main.c, right? And then I'll paste this guy, and then I'll save it. So I have that already. So the last thing I'm going to do is I'm going to create my file. And what is the file name? One list length, right? So I'll do like this and vi this, right? Okay, so the next thing I'm going to do is get my prototype back, right? So I'll just copy this guy and let me paste it here, and then insert mode, and then go to home, and I want to include my lists dot h, right? And then I want to documentation, so I'll have my list int length, right? So I have this, and count the number of elements in a list. List is single linked list, right? And then we'll have our h, which is the head pointer, let me call it that way, right? And then it's going to return, right? That's a return, and it's an unsigned integer, so it's going to return the number of elements in the list, right? And then that will be all for now, and then I will delete this, enter this, come down. All right, so because we have our standard library in our header file, so I can use the size underscore t as usual as well. So size underscore t, right? That's unsigned integer, and I'll call it probably count, right? And I'll initialize it to 0. I might leave it as well, so anyone that works for you. So you give it a space so that Betty will not complain. So the first thing you will do is you check if your age is pointing to null. So if our age is equals to null, right? If our age is equal to null, then it should just return 0. So return 0. So if not, then we can use a while loop or a for loop. So I'll just use a for loop and then my braces. Then I'll say count equals to 0. So because we are using this for loop, if we are using while loop, you can just initialize it. But if we are using for loop, I like not initializing it. Alright, so anyhow, anyone that works for you. So that's the way I do that. And the next thing is, I'll say as far as age is not equal to null, so it will count until it gets to that null part, right? So, and then we'll increase our count, right? Because we want to return our count. So the next thing we're going to do is what happens here is that our count is 0, right? So age is not equal to null. So age would come here. Where is it? Age will come here and see that okay, it is not equal to null, and then it will count 1, right? So once it counts 1, then it will go back, right? So there's a way we need to increment this age to go to the next one. If not, it's going to just keep counting this particular one, and then we'll run into an infinite loop, right? So it will never get to this null. Okay, so a way to make this age then keep pointing to this rest is by doing what? By saying our age, right? So I can give it in a braces as well. So our age will now equal to, so we'll now initialize it with the next guy, right? So our age will now be equal to next pointer, right? So our age is pointing to this guy, age is pointing here, age is pointing here. Okay, so that's what we are doing. So we say age and then point to the next, right? And then end it. So at the end it should return the count for us. Okay, so that will be all, and then let's check our code. So I'll compile with what we have here, and so our output is B. I've already added that to our gitignore, so it's not going to push that to GitHub. Okay, what happened? Oh, sorry. I think I over copied it. Let me go to home. I over copied it. It's supposed to be GCC. So let me delete this part. Yes. Alright. So I forgot to Betty it. Let us Betty our file. We'll Betty our one list, right? Okay. So let's Betty it. I hope you are right. Okay, we are good. Since we are good, let's just execute our B, and then our stuff is just 2 elements, and is that our output? 2 elements. So it means that we are good, right? So we'll git add, and then we'll git commit, and what is our commit message? We'll say should list or count the number of elements. Okay, count the number of elements in a singly linked list, right? And then we'll git push it. So once we're done with that, let's check our code to see if we are correct. So we'll come down and check your code and start a new test. So let's hope we get it right. So we're right. So see you in the next one.